Okay, start the recording. Last time we talked about consumer surplus, right? Why consumer surplus is useful. I'll just continue. So this is for your reading. Next one, we're gonna talk about network externalities. Okay, so what is network externality? When each individual's demand depends on the purchases of other individuals, what does it mean? So we have positive and also negative, okay, negative. So a positive network externality exists if the quantity of a good demanded by a typical consumer increases in response to the growth in purchases of other consumers, okay? Here is positive network externalities. The other way around, if the quantity demanded decreases, okay, so this is a negative network in a externality. What does it mean? What does it mean? So network externality means your demand depends on what other people buy, okay? Your demand depends on what other people buy. So here we have two types. The first one, positive. Which means more people buy it, you want it more, okay? More people buy it, you want more. Any example about positive externality? The Line, do you have Line? Do you have Line app in your mobile phone? Yes, because everyone in Thailand use it, so you must have it too. But if you go to China, you cannot use Line. So you need to use another one, which is WeChat. So this kind of social media, they have positive externality, right? The opposite one, negative. Which means more people buy it, you want it less. Okay, for negative externality, more people buy, you want it less. You want to be different, right? Like the exclusive handbag, if everyone has it, it's no longer special, so you don't want it. Here we have bandwagon effect, which means positive network externality in which a consumer wishes to purchase a good in part because others do. We call it bandwagon effect, all right? So this is a positive network externality. I want it because everyone else has it. This is bandwagon effect. Examples, right? TikTok. All your friends are on it, so you join too. AirPods. Everyone at the university wears them, so you want them too. Another one, Coffee Amazon. Most popular coffee in Thailand. Is it true? Coffee Amazon is the most popular. Is that right? What is your favorite brand in terms of coffee? Okay, because so here for Coffee Amazon, more branches, right? More people go. I'm gonna give you an example. TikTok. Let's see the figure, okay? This is about positive externality, okay? Positive network externality. Look at this graph carefully. When price falls, two things happens, okay? The first one, suppose the price falls from 30 to 20, okay? Suppose. So basically for this demand curve, you personally buy more, right? The price is 30, you buy at 40 units. And when the price is 20, you buy 48. So basically here, suppose, let's look at this curve, D40. So this is individual demand curve, okay? Here we have a pure price effect. When price is lower, you buy more, right? From 40 to 48. Because here we have positive network externality, so more people join, okay? More people join, so everyone else buys more too. The demand shifts right? So the bandwagon is from 48 to 80. So here you need to look at this demand curve, okay? More flatter, this demand curve, which is, this is the market demand, all right? Okay, let me write it down. Here we have pure price effect. From 40 to 48, all right? From 40 to 48, okay, this is the pure price effect. Where is the bandwagon effect? It's from 48 to 80, okay? This is the bandwagon effect. Okay, so let me give you a simple story. Think about the bubble tea drops from 30 baht to 20 baht. Okay, so you buy more. This is the pure price effect. And your friends see you drinking it, they buy too. Shops gets busier, even more people want it. This is bandwagon effect, okay? Bandwagon effect amplifies the price effect. So the final demand curve is flatter than without the externality, okay? This is flatter. Now, the opposite of bandwagon, we call it snob effect. What does it mean, snob? Negative network externality in which a consumer wishes to own an exclusive or unique good. Any example you want to share? So basically this snob effect, which means I want it because not everyone has it. Okay, you see the graph? Same as before, the price falls from 30,000 to 15,000, okay? You personally buy more. from 2 units to 14 units. Okay, this is the pure price effect because you are on the demand curve, which is D2, right? D2, okay? So the pure price effect from 2 units to 14 units. This is the pure price effect, okay? And it's on demand curve, which is D2. And right now, because there are more people buy it, right? Too many people have it now, so snobs want it less, all right? So basically, the true demand gonna decrease from 14 to 6 units because more people have it, you want it less. This is snob effect. From unit 14 to 6 units, right? That's why we have our net effect, which is from 2 to 6 units. The idea is that snob effect cancels some of price effect. That's why the net effect is smaller, okay? Smaller than pure price effect. So you see here, the final demand for snob effect, the demand curve is steeper, right? This one steeper. Please compare with bandwagon effect. Let me move back. For bandwagon, the final demand is flatter because bandwagon amplifies, okay, the price effect. But for snob effect, it cancels some price effect. So we have a steeper demand curve. Let me compare, okay, let me summarize. Let me summarize bandwagon and snob effect. For bandwagon, all right, if more people buy it, so you ask yourself, do you want more or less? For bandwagon, you want more. So the demand shifts to the right. And the final demand curve is flatter. So the example I mentioned before, TikTok, the line, right? TikTok line. Okay, let's talk about the snob effect. If more people buy it, you want less. And the demand shifts to the left. The final demand curve will be steeper. The example is the luxury bags and limited, right? Limited edition. Okay, this is the difference between bandwagon and snob effect. Okay, for the limited edition, like the limited edition grab bags, okay? Suppose there are only 100 pieces. If everyone gets one, not special anymore. That's why snobs don't want it. Snob effect reduces the price effect, all right? Exclusively loses value when too many people have it. Can you think of a product that started as a snob good, which is exclusive and niche, but became a bandwagon good once it went mainstream? What changed? Any idea about one product? Before it was a snob good, it's exclusive, but later it changed to be a bandwagon good. Starbucks in Thailand. Have you ever been to the Starbucks? Starbucks coffee? Okay, so think about it. Once a status symbol when it first opened. Okay, before it was exclusive, but right now it's just a normal coffee shop, right? It's just a normal coffee shop for many people. For your rating, okay, guys, let's do a quick review about chapter 3 and 4. Here, two big problems in consumer theory, right? Utility maximization and Marshalling demand. Expenditure minimization and Hexen demand. What is the difference? We have utility maximization, okay? What is the goal? Are you good at math? Generally, are you good at math? Okay, I also teach econometrics. You guys gonna learn it later. When I asked my students, all right, are you good at math? They said no. I said, are you good at statistics? They said no. And then I asked, are you good at English? They said no. So basically, it's quite challenging because for econometrics, have you heard about it? Econometrics. This one. It's a combination of statistics, mathematics, and economics, okay? That's why you need a fundamental skill about statistics and mathematics. But unfortunately for microeconomics, it's about optimization. That's why you need mathematics as well. So for here, we use Lagrangian, okay? You have to know how to do it. Okay, let me continue. What is the goal? Next one, subject to what? Subject to means what is the constraint, right? Because here we are talking about constraint optimization. And then what kind of result we're gonna get? So what's fixed? And what changed? also called okay, so first we have utility maximization and marshalling demand, the other way around, which is expenditure minimization. Then I'm going to talk about the difference. So what is the goal for utility maximization? We want to maximize your happiness, right? We want to maximize your happiness. And what is the constraint? Subject to your budget constraint, right? So what is the result? If we maximize our utility, we're gonna get the Marshalling demand curve for two goods, all right? What is fixed for utility maximization? Which means the constraint, right? So we fix the income. So what changed? The utility, right? Utility. So Marshalling demand, we also call it uncompensated demand. This is about utility maximization. The other way around, expenditure minimization. Okay, so the goal is minimize spending. Which subject to our utility level. So the question is that I want to get the utility level. What is the minimized expenditure that I can spend? Okay, what is the minimized money that I can spend in order to achieve that utility level? So the result, what is the opposite one? What is the counterpart of Marshalling demand? I talked last time, which is Hexen demand, right? Hexen demand. So we fixed utility here. And we change the income. And also we can call Hexen demand to compensated, right? Compensated demand. This is the difference about utility maximization and expenditure minimization. Okay, the idea is that for utility maximization or Marshalling demand, the question is, I have 100 baht. What makes me happiest? Okay, happiest. For Hexen demand, the other way around, I want to be this happy. What is the cheapest way to get there, right? Same consumer, two different questions, max happiness or minimize spending. Okay, let's move on. Here, this is the formal setup of what we've been doing all along. All right. You saw this one before, right? You are given price of X, price of Y, and income. And you need to find X and Y that maximize your utility, all right? So the objective function is our utility function. And the constraint, which is subject to the budget constraint. So the choice variables is X and Y, right? How much to buy. Okay, you read the math as we need to choose X and Y to make utility as big as possible, but you can only spend exactly M baht, right? So the real example will be you have 100 baht as your income, and there are two goods you want to buy. Let's say X is khao soi and Y is bubble tea. Basically, utility maximization is finding how much of each to buy to be happiest with your 100 baht, all right? Again, this is about constraint optimization, and we solve it by Lagrangian. Still remember these 4 steps? This is the key condition from solving the Lagrangian, okay? The optimal condition, which is the price ratio, must equal the ratio of marginal utilities, all right? Okay, so here is the condition, what I just talked about. The price ratio must equal the ratio of the marginal utility. Or what you pay, because you pay for the price, right? What you pay, what you actually pay equal what you gain, okay? You gain the marginal utility. And the price ratio, which is price of X over price of Y. This is what the market says, okay? But for the marginal utility, the ratio of the marginal utility, this is the MRS, what your taste says, okay? This basically, this is the MRS, right, of X, Y. Be careful here, we are talking about utility maximization first, all right, which is, if we solve the Lagrangian, you get the results of the utility maximizing problem. Okay, you get X, you got Y, you got U. So X and Y here is the Marshalling demand for Y and X, for X and Y, right? Px, Py, and M is the given variables, okay? It's the given conditions. Marshalling demand for X, which means is the optimal amount of X to buy. For Marshalling demand for Y, easy the optimal amount of Y to buy. Okay? And then you plug in X and Y, you'll get the maximized utility. Highest happiness you can reach. What is the unit of utility? You still remember? What is the unit of utility? Utiles, okay, utiles. So like what you did for your homework, last chapter, chapter 3, consumer behavior. If you are doing the utility maximization, the demand function you get is Marshalling demand, all right? Okay, same example as last chapter. The same Cobb-Douglas problem we solved earlier in chapter 3. Let me just remind you about the final answer, all right? The final answer. So basically, here we maximize our utility subject to the budget line. You will get X star, which is M over 2PX. And Y star, this is the Marshalling demand for Y, okay? So M over 2PY. And then when we plug in numbers, right, because Px equal 1, Py equal 2, and M equal 100, you'll get X star equal 50 units and Y star equal 25 units. What about the maximized utility, which is approximately equal to 35.36 utiles, okay? Don't forget the unit. And what is the MRS of X, Y? So it's just Y over X, which is 1 over 2. And then if we do the Lagrangian, remember the bonus, okay? We can get the lambda, which is marginal utility of income, approximately equal to 0.354. Okay, X and Y here is the Marshalling demand, okay? Let me emphasize it. I think right now you should be very familiar about utility maximization, okay? So the X and Y is our Marshalling demand. Because the question asks you find the Marshalling demand functions for X and Y, right? And here we're doing the utility maximization. Any question about utility maximization? Okay, so far so good. So next one, let's talk about expenditure minimization. This is the mirror image of utility maximization, okay? Basically, you are given price of X, price of Y, and utility here. And so you need to find X and Y that minimize your spending, which is the money here. So this time, our objective function is our budget line, right? M equal anything wrong here? So basically here should be Px times X plus Py times Y, just a typo. So here we want to minimize our expenditure and constraint subject to our utility. Here you are given the exact utility level, all right? So you read the math as choose X and Y to spend as little as possible. Okay, you choose X and Y to spend as little as possible, but must reach exactly U bar happiness. This is about expenditure minimization, right? The example is that you want to feel exactly as happy as eating at your favorite restaurant. So you need to find the cheapest combination of food to reach that happiness level. Be careful here. The utility is constant, okay? The utility is constant. Okay, if you solve this expenditure minimize problem, you'll get Hexen demand for X and Hexen demand for Y. Be careful, it's totally different from Marshalling demand, okay? This time, you are given utility constant, okay? You are given utility as constant. I think, okay, let me summarize again. Do you clear about the difference between Marshalling demand and Hexen demand so far? Do you clear about this? Utility maximization problem and expenditure minimization problem. What is the objective? What is the constraint? What's fixed? And what is free? Result? Okay, let me go through it quickly because I think I summarized it before. Just let me remind you. The objective for utility maximization is maximize utility. And the constraint is your income is fixed. Okay, income fixed. So the free, what is free? Utility is free. The result is Marshalling, okay, Marshalling demand. The other way around, you want to minimize your spending, okay, expenditure. So U is fixed. That's why U is fixed at U bar. Okay, same utility. What's free? The money. And then you're gonna get the Hexen demand. So I'm gonna use X M represent Marshalling demand. And for Hexen demand is X H. All right? Okay, let me continue. This is in-class quiz. Do you have a A4 paper with you? Or you can do it on your iPad, okay? So this time, please solve this question, all right? The problem is you need to minimize your spending subject to the utility. Okay, please find the Hexen demand functions for X and Y, and suppose price of X equal 1, price of Y equal 2, and the utility equal 25 times square root of 2. Find the optimal consumption bundles, okay? So you just plug in numbers. And also find the minimum level of expenditure. Let me guide you a little bit, all right? So the first step, you need to write down the Lagrangian. Again, please use Lagrangian multiplier method, okay? Please, okay, first step, write the Lagrangian. So here, what is our objective? Minimize expenditure, okay? So in this case, remember Lagrangian function, the objective function first, which is px times x plus py times y. And you plus the constraint later, right? Lambda times. What is the constraint? Is our utility u bar minus x power half y power half. This one is our objective function. Objective function first, and then this one is our constraint. Okay, how you get the constraint? Basically here, right? You just move x power half, y power half to the right. So u bar minus x power half, y power half. Okay, this is the first step. What we want to minimize, this is the total spending. The second part is the constraint, okay? Okay, please finish this question. If you finished, please show me. You'll get extra point. So basically, I'm done at my side. Let me stop the recording.